Hello everyone. In this video, we are going to discuss about multiplication of two complex numbers, which comes under this topic algebra of two complex numbers from the chapter for complex numbers and quadratic equations, class 11 maths. Let us consider, see, we have already discussed about the difference of two complex numbers as well as the addition of two complex numbers in our previous video, which are available in the playlist. So here we are discussing about the multiplication of two complex numbers. For that, I am considering two complex numbers, z1 is equal to a plus ib and z2 is equal to c plus id. Now multiplication means we have to find their product, that is z1 into z2. Okay, that will be equal to what? Z1 is a plus ib into Z2 is c plus id. This will be equal to what? A into c which is AC plus a into id which is I into AD. Okay, plus IB into C, so I into BC plus IB into ID. IB into ID, I into I square, B into D. Okay, now this will be equal to what? AC plus I into AD plus I into BC. What about I square? I square, its value is minus 1. So minus 1 plus minus becomes minus. Then B into D. So we can write the product Z1 into Z2 as AC, then minus BD, okay, plus I is common in this term and this term, so I into AB plus BC. Sorry, AD plus BC. So Z1 into Z2 is equal to AC minus BD plus I into AD plus BC. So this is how the product of two complex numbers is found out. You see, multiplication of two complex numbers possesses the following properties. The first one is the closure law. That is, the product of two complex numbers is a complex number. Okay, that is, for example, if we consider two complex numbers z1 and z2, their product z1 into z2, that will also be a complex number. That is what closure law states. For example, let us consider this z1 as 3 plus I5, okay, which is a complex number, and I am taking z2 as 2 plus I6, which is another complex number. Now when we take the product of these two, that is z1 into z2 will be equal to what? 3 plus I into 5 into 2 plus I6. This is equal to 3 into 2, 6. Okay, then plus 3 into I into 6, which is I into 3 into 6 is 18. Okay, then plus I 5 into 2, that is I into 5 into 2, 10, plus I 5 into I6, I into I square, 6 5s are 30. Okay, and this will be equal to what? This will be equal to 6 plus I is common in these two terms. I am taking it outside. So I into 18 plus 10. Then I square. I square is actually minus 1. Minus plus becomes minus 30. Okay, so this is actually 6 minus 30 plus I into 18 plus 10. Okay, so this is equal to 6 minus 30 is actually minus 24 plus I into 18 plus 10 is 28. So you see, Z1 is a complex number which has a real part and an imaginary part. Z2 is also a complex number. When we found out their product Z1 into Z2, we got the result as like this, which is again a complex number. This also has a real part and an imaginary part. Okay. Now, the second property is the commutative law. That is, for any two complex numbers Z1 and Z2, Z1 into Z2 will be equal to Z2 into Z1. Okay, that is, if you consider real numbers 2 and 3, 2 into 3 is equal to 6. And when you find out 3 into 2, that is also equal to 6 now. Okay, similarly for two complex numbers Z1 and Z2, Z1 into Z2 will be equal to Z2 into Z1. Now, the third property is the associative law. That is, for any three complex numbers Z1, Z2 and Z3, Z1 into Z2 into Z3 will be equal to Z1 into Z2 into Z3. That is, if you consider some real numbers 1, 2 and 3, see 1 into 2 into 3 is actually equal to what? 1 into 2, 2, 2 into 3, 6. Okay. Similarly, if you find out 1 into 2 into 3, 2 into 3 is 6, 6 into 1 is 6. So both are the same now. This is the case for the real numbers. Similarly, for complex numbers as well, Z1 into Z2 into Z3, that will be equal to Z1 into Z2 into Z3. Okay. Now the next property, the fourth property is the existence of multiplicative identity. That is, there exists a complex number 1 plus I0. 1 plus I0 which is actually equal to 1. This 1 or 1 plus I0, this is actually called as the multiplicative identity for a complex number, such that when you multiply this multiplicative identity with a complex number, that is z into 1, you will get z itself. Okay, for every complex number z into 1 is equal to z, then this 1 is actually called as multiplicative identity. Now, the fifth property is the existence of multiplicative inverse. You see, multiplicative inverse is actually denoted by z inverse or 1 by z. That is, for every non-zero complex number, z is equal to a plus ib. Okay, where a is not equal to 0, b is also not equal to 0. We have another complex number which is a by a square plus b square plus I into minus b by a square plus b square. This is actually denoted by the multiplicative inverse z inverse or 1 by z. So this is actually equal to 1 by z or z inverse, which is a multiplicative inverse of z. Okay, this is actually called as multiplicative inverse of z. And how we are getting this value actually? Z is equal to a plus ib. Multiplicative inverse is denoted as 1 by z, no? So 1 by z is the multiplicative inverse. So 1 by z will be equal to what? 1 by a plus ib. Now what I am doing is I am just multiplying both the numerator and denominator of this with a minus ib. So a minus ib in the numerator, a minus ib in the denominator. Okay, so this actually becomes what? A minus ib in the numerator. This is like a plus b into a minus b form now. A plus b into a minus b is actually what? A square minus b square. So here a is a, b that is ib. So a square, that is a square minus b square. B is actually what? I into b. So ib all square. Okay, so that is actually equal to a minus ib divided by a square minus ib all square is actually what? I square into b square. I square is actually minus 1. So minus b square. That minus and this minus becomes plus b square. Okay, so here this can also be written as a by a square plus b square minus I into b by a square plus b square. That is actually written here a by a square plus b square. Then minus ib is actually written as plus I into minus b. Both are actually the same now. Okay, divided by a square plus b square. So this is actually the multiplicative inverse of z. If 1 by z is the multiplicative inverse of z, then when you multiply that with the complex number z, you will get the value as 1. 1 is the multiplicative identity. Okay. Now, the sixth property, that is the distributive law. That is, z1 into z2 plus z3 will be equal to z1 into z2 plus z1 into z3. And z1 plus z2 into z3 will be equal to z1 into z3 plus z2 into z3. Okay, so these are the properties related with the multiplication of two complex numbers. I hope it is clear to you. Thank you.